Hello, good morning, and welcome to the webinar.
And we'll post a recording of this on a project web page that has a link to that and some other related informational resources on larger PV projects in Virginia from two earlier webinars and also some related informational resources. So once we have the recording from this session, we'll post it there too. So keep an eye out in the chat for a link to that page if you're interested. And using the email that you registered for this webinar, we'll send out a recording link once it becomes available. Our plan for this webinar is just a brief welcome introduction. Thank you for joining us. Then we have two presentations. One is from Mr. Maximilian, the head of the Agrophotovoltaic team at Fraunhofer Institute for Solar Energy Systems in Germany. And the second presentation is from Mr. Riley Murray, Senior Project Manager with Secure Futures, recently retired, both to share some project examples, project experiences from agrophotovoltaic applications. Following the second presentation, I'll release a brief poll just to get some feedback from you all, the participants in this webinar. And then throughout the session, please enter any comments, questions you might have in the chat box. After the presentations, we'll kind of circle back to those and work in the ones that we're able to. We have about 120 people that have registered for this session. So we'll record this and also share it. And I think it'll be an interesting resource to learn more about these agrophotovoltaic project experiences from different parts of Virginia and different parts of the world. Most participants are from Virginia. And also participation from about 15 other states and about 4 countries. We have people from interested landowners, personnel from state and federal agencies, university faculty, photovoltaic project developers, utility companies, county planners, boards of supervisors, various non-governmental organizations, among many others, participating in the webinar today. This is number 3 in a series on larger projects, solar projects in Virginia. I had mentioned a web page where we've posted links to the recordings of these webinars and also links to related informational resources. The highlighted link on this slide is in the chat box. I'll post it again later on. If you are interested in more information on these types of projects, I would encourage you to take a look at that web page. So different types of solar photovoltaic, solar PV projects, from small to very big. On the left of the slide, we have some smaller off-grid applications, maybe for a water pumping project, then the residential scale, and then moving to the right, the larger projects, commercial projects, and then utility scale projects, or what people call solar farms. The focus of this webinar is looking at more towards the projects on the right side of the screen and discussing what might be some agrivoltaic project opportunities for these types of projects. And that's our goal for the session, is basically to share some agrophotovoltaic project experiences from ISC, Fraunhofer, and Secure Futures. A few reminders for the session: it's being recorded, so you can access it later on, share it with colleagues. Everyone should be muted. Please enter your comments, questions via the chat box. And again, this is a brief informational webinar. We won't have time to adequately answer all questions or cover all topics during the session, but it's an opportunity to share some of these project experiences with agrophotovoltaic projects. So the larger PV projects, here is a major project map, they call it, from the Solar Energy Industry Association, SEIA, looking at projects above 1 megawatt over the United States, with the size of the circle indicating the size of the project, the color of the circle indicating the stage of project development, from construction development to operational. If we were to zoom in and look at Virginia 4 years ago, 2016, that same map of Virginia basically didn't have hardly any activities in the state of Virginia. During the last update to the major project list, which was December 2019, So about 6 months ago, we look at Virginia and we see a lot more circles, a lot more project activities at the larger PV project development in Virginia. So these projects are growing in Virginia, and people have a lot of different types of questions. One of the questions that sometimes comes up are applications to incorporate agriculture with some of the PV projects, something we'll call agrophotovoltaic projects. And again, that's the focus of this webinar, is to hear some firsthand experiences with agrophotovoltaic project development from Fraunhofer with Maximilian and from Secure Futures with Mr. Murray. So with that, let's get started. Now, before I introduce our first speaker, Maximilian from the Fraunhofer Agrophotovoltaic team, I want to share how we came to know Max or meet Max the first time. Virginia Tech's Department of Biological Systems Engineering has a senior design project course, which is a 2-semester course that students complete over their senior year with different real-world project applications. One of the student design teams this year focused on exploring an agrophotovoltaic project design for an agricultural school in Guatemala. There's the names of the project member team there. And part of their research on different agrophotovoltaic project experiences, were able to communicate with Max, who was gracious enough to share some of their resources and information on some of their project experiences in Germany and other parts of the world. So with that, we want to thank you again, Max, for sharing your time. And that's how we came to get to know Maximilian. He is the head of the agrophotovoltaic team at Fraunhofer Institute for Solar Energy Systems. So Max will share some research and project experiences from what they call APV, agrophotovoltaic work in Germany and other parts of the world. Fraunhofer Institute for Solar Energy is in Germany. I believe it's Europe's largest solar energy research organization. He is the project management and acquisition in international industry projects is his role there for the agrophotovoltaic team lead. Prior to this role, he was a research associate in agrophotovoltaics at the University of Freiburg. His master's is in economics and politics from the University of Freiburg, with his thesis on agrophotovoltaic opportunities, risks, and strategies towards a more efficient land use. So with that, Max, I'm going to hand you the controls and you can navigate your slides. And thank you again for your time today.
Thank you, John, for the nice introduction. Can everybody see and hear me?
Max, you're coming through loud and clear. Yes, thank you.
Okay, that's perfect. So thanks again, John, for inviting me and for having me here in this circle in this very special times. So it's great to exchange thoughts over the ocean here from Germany to you in the US. As John introduced, Fraunhofer Institute for Solar Energy, founded in 1981, the same year when our founder came up with this idea of using land for 2 purposes at the same time, for PV power production and agriculture, and the same year I'm born. So all starts in 81. And maybe just a short notice, I will jump over large parts of my presentation. I'm pretty sure John might share this with you afterwards, so you can look it up, all the details, to highlight really the main research findings we gained in our project, which we're having since the last 6 years in Germany here, in order to have some time and room for discussions and questions. The term agrophotovoltaics, that's what we use here in Germany, but nevertheless, I gonna try to stick to the word, the term agrivoltaics, or just APV, as we abbreviated. So the challenges of energy transition, I think that's pretty clear to most of you. Just came up with a study recently in our institute that we try to to check what is the required, the probable required capacity for PV, and it's clear that it's massive. And this scenario, it's not only pretty probable for Germany, but also for other countries. So the main question is how we satisfy this demand for electricity if we want to be serious about climate protection and extension of renewable energies. And if I'm as a researcher at a solar energy institute would tell you photovoltaic is the major source in the future, maybe you would have doubts. So I prefer to show a prediction of Shell, who's maybe, well, shows really that probably from the mid of this century, photovoltaics will definitely be the main energy source on our planet. And well, the reason for that can maybe be depicted in this short picture. You're also aware of that. It's just that PV is getting very, very cheap over the time. And so that's why the question is now, where we're gonna install all this PV capacity. Of course, countries like US, there are huge land surfaces which are available. So land scarcity is probably not the main issue in the US, but the question is maybe there are some areas of application where we can gain some benefits of integrating PV. So that's why this integrated PV strategy is a pretty big thing in our institute the last years. And there are just a few small overview which applications you can use to integrate APV. I don't want to mention all of them, but what we did is to look at the different area potentials of these integrated PV approaches. And unfortunately, the slide is still in Germany, but what you can see at the very left bar, that's the agricultural PV or APV. And the potential just for Germany with a very rough assessment, but still pretty conservative actually. So we only considered areas where we really believe that the agricultural activities might benefit, even in the rather shady German landscape. And that's much more than we actually need for our energy transition. So that's actually the main story, that if we're looking for areas, we might find them in the agricultural sector. Just an overview, I mentioned already, Adolf Götzberger came up with this idea and this small drawing there, how you can, well, get this into the realization. And well, the first thought of him was back then that actually we do not need full sunlight for PV generation. Well, back then the panels were pretty expensive, so a lot of sun will get through the panel rows, and the same applies actually for plant growth. Many plants are around which maybe even perform better if they are grown in partial shade. That's another illustration of this concept, how it could look like. After this idea, it took some years to develop actually. Only in 2000, it became a bit more relevant in Germany when we had a kind of photovoltaic revolution, and in 2010, a governmental decision to not support anymore ground-mounted PV on agricultural land. That was the moment where we decided to come back to this idea of Adolf Götzberger and started our research. And what you see at the scale here from 2000 to today, what happened, just a brief overview. The first installations we had in Europe, in Italy and France in 2011. Then Japan was the first country globally who supported agrivoltaics, mainly to support rural areas. So we see a lot of small scale systems around there, more than 1,800 from which we know. China then, 2 years after, in 2015, came up with very large systems also for, protecting the land against desertification. And then France was the first year in 2017 who came up with a supporting scheme for agrivoltaics. And today we roughly assess the global installed capacity to be around 2.4, but of course that depends on how we define agrivoltaics. So grazing sheep are below it, it's such a thing where you might think, is it agrivoltaics or not? So of course, it's a bit of a gray zone. Here, just a few concepts all around the world. So you see a huge variety, and that's how the system looks, which we installed in 2016 at Lake of Constance, south of Germany, our research plant. And now coming up to what we did within this project. So the first step was to screen which agricultural applications would actually fit below PV panels. So where are the shade tolerant crops? And so the first rough analysis revealed that vegetables, especially those who produce green leaves, are rather likely to benefit from this partial shade. Also some kind of fruits and like hops, of course, but that's also with respect to the mounting structure. So some applications which might be able to take use of this mounting structure, which you have on the field, of course, are also nice and could have larger potential. Category 0, that's the one which are rather neutral. And category minus, that's the yellow one here, where you can find wheat or corn, for example, which are rather sun-loving crops and less suited for agrivoltaic applications. Then the same principle here on a graph where you can see on the x-axis the active irradiation for the crops and the agricultural yield. So with the category plus, you might gain some yield. Of course, that's very stylized for these 3 different crops. And then we installed this research plant, and our main goal was to facilitate all kinds of agricultural practices that you can imagine. So that the benchmark was then the full harvester with a vertical clearance of 5 meters. Might be that in the US the machines are even larger, but for German conditions that was sufficient. Also the width between the pillars, almost 19 meters. And we covered an area of around 1/3 of a hectare. I'm not sure about the measurements here in the US, but that's in square feet. I'm not perfectly sure, but it's around 130 meters long and probably 25 meters width. Yeah, you also see it here, the figures. The upper edge is about 8 meters, and what we grew there together with the farming community was clover, grass, celery, potatoes, and winter wheat. The technical challenges we faced, that was on the one hand that we were perfectly clear from the very first moment that we don't want to install any concrete on the field in order to have a system which can be relocated afterwards to demount it after the project or after the lifetime of the project or the system. So you see here the so-called spin anchor system, where you have long rods drilled into the ground. We also had no fence comparison to standard ground-mounted systems, because all the electrical parts were mounted high above, where people could get and touch it somehow. What is very specific for agrivoltaics, also within the following research we did, was the use of the panels. Here we employed bifacial glass panels. And what turned out is that these are not only beneficial because they are more transparent than standard panels. So we talk about a transparency of around 10%, just the gaps between the cells where light can still penetrate. But also, as we have a more unique light distribution and larger row distances, and of course also the vertical clearance to the ground, much more reflections from the ground reach the rear side of the panels compared to ground-mounted systems. So for today, we actually had no case where we did not recommend bifacial panels, even from a purely economic point of view. Soil protection is, of course, a very sensitive issue, especially in wet years. Farmers won't like to have large machineries on their fields. So, well, we tend to say that after summer, after the harvest, when it's dry, it's the best year to install such a system. That's what you did here. And one crucial thing was, of course, rainwater distribution. So we had some uneven distributions, but fortunately not to some extent which caused any problems. But we know from other systems where this might be an issue, especially having erosion on the dripping edge below the panels. So the main results which we all were waiting for, here you see in the case of potatoes, how do the crops perform under this partial shade? In 2017, we had a decrease in the yield by 18%. 2018, then we had a very hot and dry summer here in Germany and all over Europe. And there we had some gains in the yield of potato of around 11%. And that's pretty much what we saw on average also for the other crops. 2019 is still not here because we are still evaluating it, but it's rather like it was in 2017. What does it mean for the land use efficiency, which is a very crucial criteria and frequently found in the literature of evaluating agrivoltaic systems? If you take the figures from 2018, of course, they are pretty optimistic, but nevertheless, if you imagine 2 hectares of field, the one you only grow potatoes, the other one only solar power, and now you combine them, we actually receive a higher yield in potatoes, even if you subtract the land losses due to the mounting structure, which was not depicted in the last slide. We end up at an increase in the land use efficiency of around 86%. And having in mind that that's, well, the first try in Germany, and that the technical potential, of course, should be much higher in countries which are having more sunlight and which are more arid, then I think it's a clear sign that that might be a promising approach. An important thing we also investigated in our project was the acceptance of the local citizens, because that's more and more important factor for the energy transition here in Germany, but I believe in most other countries as well. So the acceptance is, especially for wind power plants, frequently discussed. So what we did was to invite local citizens to a workshop and ask them how they have, well, how the attitudes towards agrivoltaic would be. And we did it once before. And after the installation, interestingly, after the installation, the preferences were improved actually. And overall, I can say that people would actually prefer PV systems generally in buildings and rooftop PV. But even though APV appears more visible in the landscape, they announced to prefer it compared to ground-mounted systems. So obviously they appreciated somehow the dual land use and prioritized it against the visual impact. I have to admit that this was just a minor group of people, around 20 to 25, and the results are not fully representative because it was self-selection into these workshops, but nevertheless it's maybe a sign about the rough acceptance, at least for south of Germany. Crucial question, what about the economics? So the figures we took there for analyzing this were not the figures from the real project, because that was much more expensive, but we assumed a system size of 2 hectares, which according to our system yields around 1,300, about one megawatt installed capacity. And we compared this with a ground-mounted system, and overall the costs, the capex and the opex together, amount to around 1/3 higher than the ground-mounted system in the case of agrivoltaics. But what is interesting is that we expect that the operational expenditures are actually lower, and that's mainly due to the land costs, and also like weed fighting is not anymore necessary. Of course, we have some drivers which also rise the OPEX. For example, if you have exchange modules or clean panels. In Germany, that's not the case. So that might be that in countries where you have to do a lot of cleaning activities, this might change. But at least for Germany, it was good to see that if you compare agrivoltaics with ground-mounted systems and rooftops, we are somewhere in between both. All right, so the largest challenge we are facing in Germany are actually not the technical ones, but the regulatory barriers. Today, we don't have any regulation here, and this, of course, is from both perspectives not easy. From the agricultural part, we don't receive anymore any subsidies from the EU level, and also for the feed-in tariffs for the power. It's pretty difficult. We would have to compete with ground-mounted systems, which is rather difficult. There are some examples where it might be successful, but that's not for this kind of agrivoltaics that we were talking about today, rather for almost ground-mounted systems with sheep grazing. So those already were successful in our PV tenders. So, as I said, I tried to make it short. Probably we are all still already over the time. So thanks for your attention. I believe Relay, it's up to you. And I'm looking forward to answer your questions. Well, maybe John, is it true, shall we first go to Relay and having the questions afterwards, or what was the plan?
Thank you, Max. That was a great presentation. And like he said, we'll plan to post the recording of the webinar and also the PDF of the slides there on that webpage that he mentioned. I think what we'll do now, Max, is I'm going to introduce the next speaker, Mr. Murray, and then at the end, we'll circle back to any questions in the chat box. But
all
thank
right,
you,
good.
Max. Excellent presentation. Really enjoyed the information.
Thanks a lot. Yeah, sure.
Okay, our next speaker is from recently retired from Secure Futures. His name is Mr. Riley Murray. He was a senior project manager with Secure Futures, where he'll share project highlights from the Carillion New River Valley Medical Center, where he worked with farmers, hospital staff, land developers, and installers to provide a safe environment for the solar sheep. A little more on his background. He joined Secure Futures in November 2017 as a project manager before his recent retirement. His primary focus was overseeing the various components of all the projects at Secure Futures from start to finish. One of Riley's major accomplishments while at Secure Futures is the project he's going to talk about here at the Carillion New River Valley Medical Center. His background includes extensive experience in industrial engineering, technical project management, facilities maintenance, and asset reliability, as well as agriculture from his own family farm. He's a certified maintenance and reliability professional, holds a BS and MS in industrial management and systems engineering, and graduate program certificate in applied statistics from Penn State University. Now, Secure Futures is a B Corp solar developer for schools, hospitals, and businesses located in Virginia. Secure Futures is located in Virginia. While most Secure Futures projects are rooftop solar arrays, the Carillion New River Valley Medical Center site developed undesirable land to install Virginia's largest solar project at a hospital. The site is maintained by solar sheep from local farmers to maintain the site's vegetation in order to save money, reduce the project's environmental impact, and strengthen community partnerships. Now with that, Mr. Murray, I'm going to hand over the controls to you and you can share your presentation. Thank you.
Okay, let me get that going. Okay, how's that look, John?
Hey, looks good. Looks
Okay.
good. Coming through clear. Thank you.
Okay, very good. Good morning, good maybe afternoon for our folks across the pond. Wanted to share with you a small project that we undertook at Secure Futures in implementing an environment for grazing on a solar array. The background on this solar array was installed in 2017. It was single axis tracking array. So what you're seeing in this first slide is it's sort of in the tabletop mode where it's the panels are presenting vertically straight up. They tilt 45 degrees north and 45 degrees south, or maybe it's more about east-west. But anyways, this is a tilting array, and you'll see a sort of a steel beam through the middle of that picture near the sheep. That's actually a link arm that moves those arrays through a controlled process. I arrived at Secure Futures late 2017, about the time this project was finished. And then because of my background as 40 years of having a small family farm as my side project, their side life, we raise sheep. So we've been raising sheep for like 30 years, and so very familiar with the animal. And so the challenge came to how to kind of backfit or retrofit the project to sheep for grazing purposes. This is a aerial view of the site. It's just to the I guess it would be sort of the north of the hospital, which you'll see in the background there. It's about a 10 acre site, fenced in. About 6 acres of it is under the array, and so you can give you some idea of the scale. And as most of you are aware, it's sort of a given that it's going to be fenced off, whether you had sheep in it or not. So that was, right from the start, that was at least a containment issue that was made it suitable to at least consider. So the first challenge we had to deal with, we knew we were, I'm sure there's a number of folks online that are, whether we're a commercial scale company, this would be one of our largest arrays we put in, and but as you get larger up, 2,000 acres of solar panels, becomes a challenge maintaining the landscape underneath. You can, and I've seen out west where you can be killed all the way back and put in stone or to basically kill off the vegetation. For lots of good reasons, we don't want to do that in the future. And so now you've got grasses that you want to maintain. Without going into a lot of detail, you wind up with whatever's on site. In this case, this was a general purpose mix that was also on the edge of a farm field. So it had both sort of restoration seeding that was not necessarily related to anything other than restoring ground cover. And then of course, native or nearby weeds cropped in. So it became early on quickly a challenge to deal with. So our thoughts were to move to the possibility of having a solar grazing with sheep. The cost this is a fairly small array. The cost was going to be in the vicinity of $3,000 to $5,000 a year for ground maintenance, for mowing. And so that kind of gave me a budget to work with. If I could beat that, we would be ahead of the game for that's tangible reasons, and then for the intangible reasons of just smarter use of the land. So by doing that, this is what that field looks like now, all trimmed back. This was late 2018. And then we repeated the experience in 2019. And so far, so good. It has been worked out very well for us. I've had to do a little bit of dealing with some toxic weeds. That's just a natural part of field management that you have to deal with. You don't want to poison the sheep, of course. And there are some spots where we might have an unpalatable weed or plant that does not have interest to the sheep. We might have to do touch up, but it's significantly less work to maintain it this way. Some of the things you have to deal with, again, without having this, my background coming out of industry, many years in industry with manufacturing equipment, process engineering, and reliability. thinking. This was built and designed and built without the thought of grazing in mind, so we have to deal with exposure of the equipment to grazing animals. Like I said, having dealt with them for 30 years on my farm, I kind of know the things they're going to get into. So right away, we had to think about how we're going to keep the sheep away from hurting themselves and damaging the equipment. And so that was a small amount of consideration we had to take into account. And so what I was able to find in this particular case is these are pretty much standard livestock panels. They're used in the sheep industry a lot. They're removable. It doesn't require driving any stakes into the ground. And from a maintenance standpoint, from a maintainability standpoint, easy for an electrician to pop the panel out and go in, do their repairs, pop it back together. Yet it keeps the animals away from the danger of the gear or damaging the gear. The other problem on the site, and in the first aerial view, you can look at the slides later, you'll see a stormwater retention pond. And this reflects what the pond still looked like when we're still dealing with some runoff. And of course, that's the point of a retention pond, is to settle that. Our good clay soils in Virginia, it's a lot of it wound up there. So early on, we realized this is probably not going to, it potentially could be maintained as a water source, but we were concerned that it would not be, it could potentially be, have issues with water contamination from debris and bacterial loads and things like that. So we decided that's not something we are going to worry about. We have not seen the sheep really use this that much. And of course, time of year, this can dry right out. So we realized we weren't going to have this as a regular water source. So working with a sheep producer who we connected with through the Virginia Cooperative Extension Service, we met up with the New River Sheep and Goat Club president. And so that was kind of key to developing a partnership. And we built and put in an appropriate size system for this flock. On this particular site, being about 10 acres, we decided to go with about 30 head of sheep. It seemed to be about a good fit. I estimated and we sized the system for, we looked at about 2 gallons per day per head. And we sized that up a little bit to make sure we had enough capacity for 50 to 60 gallons a day of water. And this allowed the sheep producer, did not have to be there every day, but had to bring water in and fill this tank. And that's, at least in my area of Virginia, it's pretty common to see cattle and sheep producers may have a distant field that does not have a water supply. Pretty common to carry water on a truck, bring it in, fill a tank. So that was a very feasible process for us. The other thing, because this was on the edge of a farm field, somewhat off the main campus of the hospital, but certainly accessible by the public and others to approach it. And there, maybe area farmers nearby, et cetera. Given the vegetation and the coverage, it wouldn't be uncommon to not even realize there's sheep on site, and potential for, we do keep the gate locked, but there's potential for someone to forget or not be aware. So we want to be very aware that to include, in addition to the fencing, that we make sure people know that there is animal livestock on site. There's not a full-time person supervising or watching the site. We do have a webcam to kind of look at the general state of the array and vegetation, but certainly not a major security system. So we're kind of relying on the goodwill of people on site, on the Carillion site, as well as nearby farmers. That has not been an issue, but it's something to think about, that's part of the process. So far so good. We did 2 years. I left early this year, but it looks like that process will continue. Kind of my big observation of this is it's all about making a connection. If you're interested in this process, making a good connection with a local sheep producer. Virginia Cooperative Extension Service is an excellent resource and facilitator of that process. From a sheep producer's perspective, what is attractive to these arrays is these are often land that have not been in heavy grazing use, and dealing with different parasites in sheep is an issue. And so sheep producers are always looking for land that is clean and has a low parasite load. And that was particularly of interest to the sheep producer that we employed. And it has worked out well for him. The sheep love the shade in the hot Virginia sun. And that has worked out well, and seems to be a very, very good environment for them. Let's see if I have anything else I want to cover. Here's my contact information. I have, like I said, I've retired full-time from Secure Futures, but I'm keeping my foot in, teach part-time occasionally up at JMU, and always glad to help folks out with this kind of concept if they have questions. I'm trying not to run too much over, John. I'm going to stop here. It was just kind of a highlight walkthrough. One thing I wanted to point out at the bottom right of the slide, I think is an excellent resource beyond what I could share, is there is a organization called the American Solar Grazing Association. You search that on the web. I don't know if that link will work in the PDF file, but they have a nationwide kind of developed a nationwide network of folks that are involved in this. I presented some of this content to that group online, and I wound up talking to a sheep producer in New Jersey who was doing this as a business and moving her flock from solar array to solar array grazing, and easily up in the 25 to 30 acre range was her business model, and it was working well for her. And there's always, as you can imagine, there's always considerations of the interaction between technology and equipment and livestock. And so, she seems to have worked through all of that. And I won't dwell too much on that other than say that's out there. And the only other point I wanted to make, I mentioned to John early on, we'll share it in the notes from after the conversation's over. One of the last sort of agrivoltaic, or at least the intersection of natural habitat and solar arrays that I would want to highlight that Virginia is doing an excellent job in is they have developed what's called a pollinator smart solar program through the DEQ and DCR. There's a web link to that, and that has taken off very well. And one of my next projects I was going to pursue, did not get a chance to finish, was a pollinator-friendly solar ground mount solar array at elementary school. But that is some of our cohorts in the industry have already done that at another elementary school. So I'm excited to see that happening. And that's another opportunity that is complementary to agriculture, is developing, if you can use this land, have it be pollinator smart, and also look at the opportunity to have the intersection between grazing the sheep and having pollinator vegetation, friendly vegetation. So with that, I'm going to wrap up, John, and let you take questions.
Great. Thank you very much, Mr. Murray. Great presentation. Very interesting projects to hear about, and thank you for sharing those experiences and those photos with our audience here. I'm going to share my screen, and while you're entering any additional questions into the chat box, I'm going to release a question of my own here for the participants. It's a poll question, just a single question, and it's just to get some feedback on the session here. So on a scale of 1 being low, to 5 being high, please rate how this informational webinar helped to increase your awareness of various types of agrophotovoltaic projects. And it's an anonymous poll. I appreciate any feedback you share through the poll, or any additional feedback through the chat box, or I'll also put my email address in the chat box too if you'd like to follow up afterwards. Now what we'll do is scroll through the chat box and look at some of the questions here. Max, I know that there was one regarding the assessment of the different types of plants to incorporate with agrophotovoltaics from the, I think it was 0, 1 to 2. If you could describe that classification again, I think that would be helpful.
Yeah, thanks, John. But I think it's important to mention that this classification was a very rough first assessment. And what we've seen during our results, that even though if we are, for example, in the category plus, which would benefit from partial shade from less solar irradiation, there might be some years where the climate just overweights the expected effects which you might have on average. So as it was answered in the chat, 0 would be neutral. Well, depending on, of course, the share which we deduct from the available sunlight. So that's all in the range between, let's say, 20 to 50% of light reduction. So that means that depending on the density of the PV panels, we have still 50 to 80% of sunlight available for these plants. And minus, per definition, that's the crops, which, well, are rather suffering even for minor shading ratios. So I hope that clarifies a bit. So I think the takeaway is that it's nice to have this illustration, but for sure, if you want to really be sure about the single crops, we have to first look at the climate conditions there, and secondly, also the types individually, and also the varieties of the species is another issue which could change the whole game again.
Great. Thank you, Max. Mr. Murray, a question for you. Do you know how the plot there at the Carillion solar sheep project is zoned and taxed? Did the tax status vary due to the presence of sheep with an agricultural application?
As far as I know, I don't know for sure, but looking through a lot of the project documentation over the initial years, I don't believe there was any impact to taxation, as far as I know. I believe this land was all owned by the medical center. It was the way, like often happens in adjacent land, because it was boundary area to the property. A nearby farmer actually cropped it, but it wasn't actually part of his land. So I think this was all. I don't know what the zoning was, but I don't believe there was any big zoning issues, and I don't believe there was any taxation changes related to that. But that is a great question, and definitely in the minds of a lot of people that I think as they deal with their local government, their zoning processes as to what is the impact of having ag land with photovoltaic, but also keeping some ag use in mind. I think that's going to be a healthy question by these boards of zoning approvals.
Great, thank you. And question, I think for Max here. Max, are you aware of system design tools, decision support tools? There's a system advisor model from our Department of Energy, National Renewable Energy Lab, and other kinds of tools like that. But are you aware of any design tools unique to agrophotovoltaic project design?
Well, one design tool, maybe if you call it like this, is of course the simulation of the solar distribution around the system, below the systems. So, I mean, of course, it depends on the kinds of crops that you're gonna grow. Some depend more on a unique or equal light distribution, some less. For example, if you have perennials, and like imagine you have fruit trees just in rows exactly below the PV panels, then of course you should measure the light effect directly there, also on a vertical line below the panels. But in general, what we try to do is to get is a distribution where you have almost perfect and equal light conditions. That's one tool which facilitates to avoid that you have some areas on the field where you actually should harvest earlier or at a later stage. So this situation would definitely not be nice in the case of wheat production, for example. Other tools you might use, well, I think a wide range of tools are pretty close to the PV sector, where you can design the projects. So the question is how flexible they are with respect to the elevation to the ground. I'm not really sure if this answers your question, but that's at least the tools I can think about spontaneously now.
No, that's very helpful. So some shading analysis tools and some more PV tools. Thank you very much, Max, for those insights. Let's see, a lot of questions coming in here. Let's see, Mr. Murray, with the experiences with livestock, in this case sheep, do they, aside from enjoying the shade from the panels, issues with them leaning on or rubbing up against the panel supports?
Yeah, great question. I obviously went pretty fast. I had some more slides on what we did. Like I said, having been a sheep producer myself and actually have a solar array on our farm, yes, it's a concern. And if you plan ahead and design your wire management, design your array height to get it up, north of 3 feet, 36, 42 inches like that, it's less of an issue because this array was a tilting, tracking array. It did go low. So far, by doing better wire management, some extra protection on wiring, kind of excluding out of any of the control panels, it's been a very minor problem. One of my other roles was sort of maintenance and reliability for this organization. We had tracked it with maintenance work orders. Have not had calls to the site to repair a wire pulled loose by one of the sheep. So, but being that's the other hat I wear, deeply concerned about that. I was probably the one most worried about it, having been in manufacturing and around equipment. So far, so good. But the best way to do it is deal with it on the front end of the design for maintainability, design for resilience to sheep being around it. The structures themselves are pretty tough. I hadn't seen any issues with that being a problem. We did have one fatality last season, and we think what probably happened is because the tilting arrays move over time and get pretty low, and we had one ewe injure herself, I think on a corner, caught, must have been running afraid of something, and had a unfortunate incident, and it died. But so far, so good. I mean, we have to be realistic that kind of thing happens on a normal farm, separate from PV arrays. But yes, that I have, so far, so good. We took all the precautions I could think of, and they have been getting along fine. The array movement in a tracker is so slow. It does not like it's going to catch an animal or anything like that. It just moves fairly gradually, makes good bit of noise, so the animals tend to learn that sound in that environment and move away from it. But so far, so good. But if I had to do over, I would be designing knowing that I have an animal wandering around underneath it, and I keep all my wire up high and out of reach.
Great, thank you very much. A question for you, Max. Can you give us an idea on the relative cost of mounting the panels on these high clearance arrays, say 5 meters, versus the more conventional lower to the ground installations?
Yeah, of course. It's a very crucial question, of course, regarding the economic and performance of agrivoltaic systems. In our prototype, I think we had probably the very upper edge of the costs. So we, in our cost analysis regarding the material costs, we expect on average a factor 5 compared to ground-mounted systems, and the installation higher by a factor of 3. So of course, then you can think about if you go down with a vertical clearance of 3 to 4 meters, that would be, of course, a bit lower, the factor. And that's probably the range which we would expect for agrivoltaic systems.
Great, thank you very much for that answer there. There was a question also, I think, for you, Max. Looking at, I think you shared some annual financial analysis information across the production systems in a base case, but life cycle costs, say net present value of an APV system. What do some of those numbers look like? Do you all have any insights into that yet, based on your experiences?
Well, actually, the cost of electricity that I showed before, where we range around 8.3 or something euro cents per kilowatt hour, that's actually already including the net present value, because you just divide all the electrical yields over the different, like all the expenditures over time, divided by the kilowatt hours you produce during the lifetime.
Okay.
So it's already in there actually. Yeah, and as all dynamic calculations, it depends pretty much on the discount factor. So this might change from region to region.
Great. Thank you very much for clarifying that. Now it's 10 o'clock. There's still some questions here, but what I think I should do is go to Mr. Murray and just see, Mr. Murray, if you have any kind of closing words, and then Max, I'll hand it over to you for the same, and we'll close out the session. Thank you both again. So Mr. Murray, any closing thoughts?
As I said at the tail end of that presentation, you have my phone number and email. Please don't hesitate to reach out to me. I'll try to answer any questions I can, and elaborate on anything that wasn't clear and share you my experiences. So yeah, more than glad to take a follow-up, and I'll share that Pollinator Smart link, or have shared that Pollinator link with John. He'll have that as part of the material that you can link out to. There's an excellent presentation by that group that was done as a webinar earlier this year that can, more than I could ever cover, is in one webinar. You could watch that recording and understand how you might involve a pollinator habitat in your array projects. And
Great. Thank you very much, Mr.
Okay,
Murray.
sure, that's all I have. Thank you.
Thank you for your time. And Max, any closing thoughts?
Yeah, John. So first of all, thanks for the invitation, and everybody for your attendance. From my side, what I would like to share is our first international agrivoltaic conference, which we will have in Europe, in south of France, end of August. So I'm not sure about the travel regulations in August between US and Europe, but if you are interested and have any chance, we are happy to welcome you in Perpignan. So that's close to the Mediterranean Sea, beautiful place there to exchange ideas on agrivoltaics. It's a 3 days event. So afterwards you might have the chance to have a look around the area in south of France, which might be a nice vacation. Apart from that, I would also be glad to stay in touch. John, I'm sure that we will be in touch, and if you have further questions or thoughts to exchange, yeah, I'm looking forward to answer questions or to stay in touch, no matter which aspects of agrivoltaics. Yeah. So
Cool.
Have a great day, and back to you, John.
Great. Thank you very much, Max. And thank you again to you both for your generosity in sharing these project experiences. It's from my vantage point, it's been a very interesting webinar. Appreciate the presentations you all put together and the time that you shared with our audience here. So thank you very much. And like I said, we've recorded this and we'll post a recording as soon as it becomes available. So with that, I'll close out the session. And again, thank you to everyone, and you have a good day.